Okay, welcome back. This is the third inference video, the underlying logic of Aunt Belinda. And watch out, we're gonna be kind of philosophical here. We're gonna get into the epistemology, and in order not to make it too weighty, I've split it up. So I'm gonna try to make this one shorter, but there's more to come. All right, we're gonna go back to rain and wet streets. This is the logic stuff you may remember. So if it is raining, then the streets are wet. This is our classic statement. It's a conditional statement. In boxes, it looks like this. If it is raining, the streets are wet. Either of these things are either true or false, and if the first one is true, the second one is true. Now there's an important corollary to this, that if the streets are not wet, then it is not raining. If you need to stop and think about this, do that, but you also might want to look at this diagram. This is what's called an Euler diagram. The yellow circle represents it's raining. The bluish circle is streets are wet. Notice anything that's in the it is raining circle is also in the blue circle. Streets are wet. So if it is raining is true, then streets are wet is true. There are ways that the streets can be wet and have it not be raining. Our classic explanation is a water balloon fight. Okay? So if you know the streets are wet, you can't tell for sure that it's raining. But if you know the streets are not wet, you're outside the blue circle. You're certain that you're outside the yellow circle. So if the streets are not wet, you know it is not raining. Onward. How does this correspond to good old Aunt Belinda? Well, we had this distribution of statistics. This is our sampling distribution in the condition that the coins were fair, and we flipped 20 of them, and we had no powers. And so in that case, we got between 6 and 14, generally, 6 and 14 heads in 20 flips. So if Belinda has no powers, then she'll get 6 to 14 heads. Let's look at this in boxes. If Belinda has no powers, and it's a fair coin, then she gets 6 to 14 heads in 20 flips. Here's the Euler diagram. See, every time she's fair and has no power, she has 6 to 14 heads. There may be other ways to get 6 to 14 heads, but we don't care about those. The thing is, if it's fair and has no powers, you get 6 to 14 heads. The corollary is, if it's outside the green circle, then it's outside the yellow circle. So if you get 16 heads, which is outside the green circle, then either she has powers or the coin is not fair. See how that works logically? So we've gone, what we're doing is we're showing that null hypothesis, the no powers thing, showing the null hypothesis is not true. Now, before we leave this video, we're going to go on a little digression. Here comes the digression. So, Belinda has no power, she'll get 6 to 14 heads. Really, what we're interested in is, the truth is, she'll usually get 6 to 14 heads. What does the insertion of this word usually mean? It means that the diagram changes slightly. That is, this word usually means that that little circle moves a little bit off, so there's a tiny bit of the circle that's not inside the yellow circle, that's not inside the blue circle. That corresponds to the two tails of the distribution. What does that mean in terms of our logic? This is where we've said that it's possible, but not plausible. It is so unlikely that when Belinda gets those 16 heads, we don't think that the null hypothesis is true. We reject the null hypothesis. That's it for now. Stay tuned.